So for completing the square, the first step you're going to do is you got to move all your numbers to one side and have your variables on the other. So I have x squared plus 2x equals 4, right? Because I added 4 to both sides. Then the process for completing the square is I look at the middle term, the b term. I look at the b term, and here's what I do with the b term. I take half of the b term, so I take half of b, and then I square it, and then I add it to both sides. Both sides, because back in the day when we did a little bit of pre-algebra and algebra, whatever you do to one side of the equation, you have to do the other side of the equation. So I look at the b term. Here's my b term. Here, my b is 2. So I go, all right, going to go over here. I'm going to take half of 2. I picked a nice easy one because half of 2 is pretty easy to figure out. Half of 2 is 1. So this value inside here becomes 1. And then I square the 1. All right, so if it's squared, 1 squared is, luckily, again, a nice easy number, 1. So I'm going to then add 1 to both sides. And here is why completing the square is related to what we already did in class on the boards when we went through all those problems. I now have an equation that I can factor, and it's going to equal 5 because 4 plus 1 is 5. I'm looking for two numbers that multiply to 1 and add to 2. They multiply to positive 1. Really, my only options are 1 and 1. Do 1 and 1 add to 2? Yes, I have x plus 1 and I have x plus 1. Or really, I have x plus 1 times itself, which means I have x plus 1 squared equals 5. And then we go, oh, wait a second. I need to solve. My entire left side is squared, so I can, to reverse that, take the square root of both sides. I'm left with x plus 1 equals plus or minus the square root of 5. This is remembering that plus or minus piece. And then to solve for x, I'll have x plus 1 equals 5, square root of 5. My other equation is x plus 1 is the negative square root of 5. So when we say it's plus or minus, that's what I mean by plus or minus. I'm going to end up with two possible equations there. And then I need to solve for x, subtract 1. X equals negative 1 plus the square root of 5. Over here, x equals, subtract 1 from both sides, negative 1, minus the square root of 5, which if you had written down what we just did on the previous slide, those are the exact same values we did with the quadratic formula. Does this work every time? Yes. So if you can't memorize the quadratic formula, you can get to the exact same place using completing the square. So we're going to solve this one also by completing the square. So again, the process is move all of my x's to one side, move all of my numbers to the other side. So I'll have x squared minus 2x. They stay there. I need to move that 10 to the right side. I do that by adding 10 to both sides. Not going to show the step. We've been doing this a bunch. So now I have everything on the left, everything on the right, and then I'm going to go to the steps for completing the square. I'm going to find what the original b term was, which was negative 2. I'm going to take half of b. So half of negative 2 is negative 1. And then I'm going to take this whole thing and square it. So what I end up with is a positive 1. And what that means is I'm going to then add x squared minus 2x plus 1, and over here 10 plus 1. This value that we get, I add to both sides. And then on the left, I'm trying to think, can I factor this? On the right, I just simply add them together. And I'm looking for two numbers that multiply to a positive 1 that add to a negative 2. If I've done this right, and I've completed the square the right way, it will be the same number in both of them. It multiplies to a positive, so it's either both positive or both negative. The middle number is negative. That means they're both negative. negative 1, negative 1. X minus 1, which is x minus 1 parentheses squared equals 11. I'm going to square root both sides, and I'll have x minus 1 equals plus or minus the square root of 11. Now, you can still put the parentheses on there if you want, because when you square root, you are doing the inverse, inverse of squaring is square rooting. And then I have two equations. X minus 1 equals the square root of 11, and x minus 1 equals the negative square root of 11. Add 1 to both sides. X equals 1 plus the square root of 11. Just be careful you don't combine those two. That square root traps that number inside. It can't be interacting with just anything else outside. Add 1 to both sides here. X equals 1 minus the square root of 11. If you would run that through the quadratic formula, you get, again, the exact same solution. Assuming you keep track of your negatives, showing all your work, doing all those steps. And the great advantage to this is this will work as long as the leading coefficient up here is 1. If it's not 1, we have to do something different, which is, why I get to teach and you get to learn, because we're going to do another one where the leading coefficient is not 1. We're going to go with 3x squared minus 9x plus 8 equals 0. I will begin with the same steps I did on the last problem. I'm going to move my variables to the left and my numbers to the right. 3x squared minus 9x equals negative 8. Then, what I'm going to do is on the left side, I've noticed I can factor. I can factor a 3 from both of them. 3 parentheses x squared minus 3x equals negative 8. Yes, I left that giant space there on purpose. So now what I'm going to do is I'm going to look at what's going on the very inside of this set of parentheses, and I'm going to look for my a and b. My a is 1, my b is negative 3. So when I'm doing it like this, I have to factor it first before I find my b is negative 3. And then I'm going to take half of that. So half of b is negative 3 over 2. My recommendation, leave it as fractions. Decimals get a little bit complicated. Trying to keep track of them. And then I'm going to square the whole thing over here, square the whole thing over there. So I end up with getting 9 over 4. So plus 9 fourths. Plus 9 fourths. But unfortunately, this actually isn't 9 fourths. And here's the reason why. I know if you wrote it down, you're like, why did you do that to me? The 9 fourths is being added inside the parentheses. And the inside of the parentheses is being multiplied by 3. So if I added 9 fourths here, what I actually added to the entire side is 9 fourths times 3, which is 27 fourths. So adding 9 fourths to the left side inside of the parentheses is the equivalent of adding a complete total of 27 fourths to this side, because it's the 9 fourths times 3. So over here, it's the 27 fourths. So then I'll have 3. And you might look at that and say, but how do I know how to factor that? This last term is going to be 3 over 2. Which was this number over here. Is it going to be plus or minus? Well, they have to multiply to a positive and add to a negative, so it's going to be minus minus x and x. So then I have 3 times x minus 3 halves squared equals, and now I'm going to do a little Negative 8 as a fourths is negative 32 fourths. Right? Negative 8 times 4 is negative, so that's 32. Negative 32 fourths plus 27 fourths is negative 5 over 4. Ends up being a little bit easier. Negative 5 over 4. To solve for what's inside the parentheses, I'm going to divide both sides by 3. I'll be left with x minus 3 halves squared. Divide by negative 3, which is the same as multiplying by a third, is negative 5 over 12. And now, at this point, I can recognize that I have no real solutions. How do I know I have no real solutions? I've been doing this a bunch of times. You have been doing this a bunch of times. And I have a negative number. I'm going to take the square root of a negative number. What number times itself is negative? There is no number times itself that's negative. So at this point, I would say there are no real solutions because I cannot take the square root of a negative 5/12. Where your next math class is going to take you is you'll actually find it. So to foreshadow, square root of negative 5 over 12. I'm going to bring this up here. So I'd have x minus 3 halves equals I times the square root of 5/12. I is the square root of negative 1. So this is like bonus material, not on the test, but seeing where things are going. I is what we call imaginary number, but the fun thing is they're not actually imaginary. They really do exist. There's whole graphing. There's an entire set of engineering principles that go into imaginary numbers. You just got to get over the fact that we call them imaginary. But back in the day, when they called them imaginary, it's because it's not a real number. Well, what do you call something that's not real? Imaginary. So and unfortunately, the name stuck. What it actually now becomes is called complex numbers. So it's a complex number. I'm going to add 3 halves to both sides. X equals 3 halves, because if I add 3 halves here, add 3 halves there, I will get 3 halves plus or minus, right, because it's a square root, plus or minus I square root of 5/12. And then we'll do some other things later on where you'll rationalize the denominator, and then you'll do simplified radical form on this as well. To find then a final solution. But these would be considered the 2 imaginary roots, or zeros, of your original equation, 3x squared minus 9x plus 8. So what does that mean graphically? It means this is a parabola. The first number is positive, which means it opens up. If I were to graph it, it's going to open up, and it's not going to intersect the x-axis. As I've discussed in the past, what we're doing when we're finding zeros is we're finding out where it intersects the x-axis. If it doesn't, then you have what are called imaginary zeros, or imaginary roots, because it never actually intersects. We started the same process like we did the other ones with negative 16t squared plus 32t equals negative 200. Move the numbers to the other side. You can factor, or, and other people did this as well, you can just divide everything by your leading term. If I divide this by negative 16, this by negative 16, and this by negative 16, you can get to the same place without having to worry about what to do with it out in front. Here's what I mean. So this ends up being negative 16 over negative 16, just t squared. 32 over negative 16 is negative 2t. And then over here, negative over negative is positive, and I'm not going to do that in my head, so I'm just going to leave it as 20 over 16. And now it looks a whole lot closer to what we've been doing. Now I can say, great, here's my middle term b, which I'll have over here on the side. So I've got b is negative 2. I'm going to take half of b. That's negative 1. I'm going to square it. That's positive 1. So I add 1 to both sides. On the left, it factors into t minus 1 and t minus 1, which is t minus 1 squared equals 216 over 16. If you're like, wait, what? Because 1 is 16/16, common denominator to add. So then I have 16 over 16, so 20 plus 16. Some of you did it another way and you still got the same number. 216 over 16. Then square root t minus 1 equals plus or minus the square root of 216 over 16. So then my two equations will be t minus 1 is equal to positive 216 over 16. And t minus 1 equals negative 216 over 16. Add 1 to both sides. T equals 1 plus 216 over the square root of 6, or over 16, sorry. And t equals 1 minus. I'm running out of space down there. Oh, I didn't mean to shrink just that. 1 minus square root of 216 over 16. And you all did this. This was 4.67? And this was negative 2.67. So in the context of what I said, if this were a problem, it's probably coming from a word problem that says, I have a projectile that's launched from the top of a 200-foot building at a velocity of 32 feet per second. This is my gravity constant. Gravity always acts on anything that you project. Negative 1/2 gt squared. When will the ball, rock, apple, whatever it is you're launching from the top of this building, when will it hit the ground? When will its height be 0? At 4.67 seconds and negative 2.67 seconds. And then you need to ask yourself, do these answers make sense? This does not make sense. I cannot have negative time. But luckily, we think, pretend that's terra firma, that's the ground. Here's my building. I'm going to launch something up, and then it's going to come back down, hit the ground. If I were going to map that as a graph over time, at time 0, my ball is at, and it's going to be like a interesting graph here. So if we go call that 200, that's the top of the building. Over here at 4.67 seconds, it's going to be right there. And it's going to do something like this over time. It's going to go up and then come back down. But it's a parabola. It had its maximum height right about there. We'll pretend. Not a very good graph. I'll make my dot bigger. There we go. There is the top part. But this is where it would have started had it started on the ground. That is negative 2.67. So in context of what I'm doing, this doesn't make sense because you can't go back in time. But that's what it was. This is where I started. Started at the top of the building and launched it up. And this is over time. It's going to go up and then come back down. The reality is it's going to go up and then come down and just miss the side of the building, hopefully, to either hit the ground if I'm launching it vertically. But if we map it over time, this would be then the height, h of t, the height of that function over time. And that's how completing the square. Now again, I could have taken this original equation up here and I could have cranked it through the quadratic formula. But you look at those numbers like, oh, that's going to be big. Those are going to be some giant values. Negative b, negative 32, plus or minus the square root of b squared. So you got 32 squared minus 4 times negative 16 times 200, all under the square root. Again, it's a large number. If you do it all correctly, you'll get this same answer here and here. And then you have to recognize and say, well, obviously, this is my answer. This is when it will hit the ground because this doesn't make sense in context of the word problem that this would have been generated from. I can't have a ball hitting the ground if I launch it at negative 2.67 seconds. Because you start time when you start time. If I could go backwards in time, obviously that's what it would go back to. But that's not what it is. All right then. So